Alright, trying this one more time. Like the third or fourth time I've had to do this. Okay, so we're going to do some right angle trigonometry. And a couple of notes that I'd like to make are for the sine, cosine, and tangent. So we have sine, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Now, each of these have differing ratios. In this case, it's opposite over hypotenuse. Cosine of theta would be adjacent over hypotenuse, and tangent theta is opposite over adjacent. Now, these three, or out of these three, you're going to see tangent normally used the most simply because of the way right triangles are set up. There's also Pythagorean's theorem, which is, of course, a squared plus b squared equals c squared, or c equals the square root of a squared plus b squared. Let me write that out here. Okay, so we have these couple of things, and one more thing is that the sum of all angles in any given triangle for plane trigonometry. So we have angle theta angle 1 plus theta angle 2 plus theta angle 3. They all equal 180 degrees. So that's an easier way to find, maybe a missing angle or something of one side or the other. So let me go down here just a little bit, and let me pick a different color. So now let's look at a couple of examples. Well, let's look at a normal triangle here, and we will label these sides A, B, and C. Of course, this is a right triangle. Each opposite side is opposite to the angle. So this side is small b is to angle B, as angle A is to angle C, and this comes from what's called the law of sines, and which really is beyond the scope of this. But in this case, let's look at a simple problem here where we're given a triangle, a right triangle, with three sides, and we know that this side is A, it's equal to 3 units, B is equal to 4 units, but we don't know what C equals. Well, in this case, this is where Pythagorean's theorem comes in handy. We can look at and see that we have two A's, or we have an A at least, so 3 squared plus 4 squared, and this is going to equal C squared. Now, so that's 9 plus 16, of course, equals C squared. 25 equals C squared, and then we'll take the square root of both sides. Equals C equals plus and minus 5. Now, we have the plus and minus simply because the radicals always give us a positive and a negative. But in this sense of trigonometry, we can't have a negative length, so we'll just keep it positive 5. Therefore, in this case, the hypotenuse itself is equal to 5. Now, that's basically how you solve any of these right triangle problems where, I've got to find my mouse. Okay, there it is. Where you're given a certain number of sides, or lengths of the sides, I should say, and you need to find one or the other. You just plug them in and simply figure it out and go from there. So let's look at another example. And this one uses the ratios that we looked at the beginning of this video. And let's look at another triangle. And I try to change the colors just to help break the monotony up here. Of course, it's a right triangle. This angle happens to be 30 degrees. And this side happens to be 22 yards. Okay, so we're given an angle and we're given a side, but we want to know what this side is, in this case B. Well, we can look at these ratios and we look at these from the perspective of, here's my angle, and this side is going to be opposite. Of course, B is going to be adjacent. So if we look at that, we're looking at the tangent ratio. So this will actually set up as tangent 30 degrees equals 22 over B. Now, we don't know what the adjacent side is, so we will have to solve this for B, and we will end up with, I'm going to skip a few steps here, 22 over tangent 30 degrees equals B, which is approximately, let me throw that into the calculator here, 22 divided by tangent 30, about 38 yards. So this would be our answer for B right here, about 38. Now, so moving on, let me scroll down here. This chair is about one of the squeakiest chairs on the face of the planet. And let me grab the blue, and I will do another one here. Just ignore that exit, that's my tablet being strange. And this one asks a couple more things. It gives us a triangle, and my triangle kind of looks sick, but it's alright, we know it's a triangle. We know it's A, B, and C. It's a right triangle. In this case, this angle here is 26 degrees, and this side B is actually 22 yards. But we don't know what this one is. We just have no idea. So we look at this again, and we're looking at it from the perspective of, here's our vantage point, here's what we're needing. So it's opposite, which we don't know, over what we do know, which is 22, the adjacent, equals, and of course we're looking at tangent yet again at 26 degrees. So this will end up being 22 times tangent 26 degrees is approximately equal to tangent 26 times 22. It's 10.73. 10.73, so that's approximately 11 yards. Now, it also says, what is the measure of angle B? Well, as soon as I find my mouse here, or my cursor, what is this angle? Well, we're given two angles. We have the right angle and the 26, so we know that 90 degrees plus 26 degrees plus some unknown degrees is going to equal 180 degrees. So 90 plus 26 is 116 degrees plus x equals 180 degrees. Of course, we're going to subtract 116 from both sides, giving us 64 degrees. 67, yes. Okay. So angle B equals, oops, let's try that again. 64 degrees. Okay. So that's another example of some of the things that you will encounter. What in the world? I have a hard time following my cursor on here. I need to maybe put a little thing on it that has a little beacon that says, here I am, here I am. So anyway, so let me break this up yet again. And here's another one that's kind of odd. And we're looking at A, B, C. Of course, this is a right angle. Now, this angle, again, is 36 degrees. And we're given the hypotenuse as 67 centimeters. Well, we have a hypotenuse, we have this adjacent angle and we have an opposite angle. The cosine function actually has the adjacent over hypotenuse. So we can use that one in this case. So cosine 36 degrees equals adjacent, we have no clue what that is, but 67 we know is the hypotenuse. So we can multiply 67 by cosine 36 degrees to give us b, which ends up being 67 times cosine 36, 54.20, so about 54 centimeters, approximately 54 centimeters, that's an M. So this side, B, equals 54 centimeters. Now, this is just one of those random times where you're going to see this. Maybe they give you some oddball side here or some oddball number. But in the end, you end up with the same looking equation and you solve it in the same manner. Another interesting problem that I had seen, and this is a triangle yet again, is they give you two triangles and say, okay, this is a right angle, and let me change the color here just to make these numbers stand out. This is 520. This angle is 41 degrees, and this angle is 29 degrees. Now, they want to know what is the length of this entire side here. Well, that would be an easy addition problem, considering that we have 41 and we have an adjacent, but we don't know the opposite. So opposite over adjacent, which is the tangent ratio. So tangent 41 equals opposite, which we don't know, we'll just leave it as O, over 520. So we end up getting 520 times tangent 41 degrees plus, and then we're going to look at this other portion. This is the same thing. We don't know this hypotenuse here. We have no idea what this is, but we do know that we have this 520, and we have this side that we can figure out by using the same thing with the same ratio. Oops, not 500. That should be 520. So 520 times tangent 29 degrees. So that equals the first one here. 520 times tangent 41 is about 452. Where is my 452 plus tangent 29 plus times 520, 288.24. So this is 288. I'm having a hard time finding my mouse again, cursor, plus 452. Nathan, there we go. Which gives us about 720. 720. My stuff is really not writing for some reason. Not 720, that's 740. What did I get 720? Let me just break that out again. 740, about 740. I didn't write down the units. What is the units? Whether it be yards, centimeters, inches, feet, donkeys, ropes, goats, whatever you happen to be measuring with here. So now, please don't make fun of my drawings. But here we have a helicopter, and we have it straight up and down to this island down here. I guess we can draw an island here. Oh, island. Okay, this is turning out better. And It's this big long triangle. Okay, there we go. All right, this is working better than last time. Okay, so it's a right triangle, and this is actually number 45 in the book, which is on page 583. This is number 45 on 583. And it talks about this helicopter, and it's wanting to know how far this thing has traveled from a given point. And let me do this in red. But this actually falls back to basic geometry, because we're given the same distance from here to here and from here to here. And geometry states that any time that you have the same distances, then the corresponding parts to each triangle, corresponding parts to congruent triangles, are equal. We then look at this fact that this side over here is actually 1,000 as well. And we're given this angle, which is 36 degrees. So we're looking at a tangent here. We have a tangent. We don't know what the B side would be. We don't know what this is. However, we know what the adjacent, or the opposite side is, which is 1,000 over the adjacent side. So we have the tangent of 36 degrees equal to this. Now, after a little bit of manipulation, you're going to end up with B equals 1,000 over tangent 36 degrees. Now, this gives us an answer of 1,000 divided by tangent 36 of about 1,376, where is my, approximately 1,376 feet. These are feet. FT. And that means that this thing has traveled from here, or it's 1,000 feet up in this case. Or I'm sorry, 1,376 feet from this point all the way over to the, let me undo that. Let me undo that. That's just horrible, atrocious. It's an atrocious piece of nature that should never exist. There we go. There. So this is approximately 1,376 feet, which is, of course, what the red lettering in my textbook happens to say as well, which is fine. So this is just the basics on 10.6 for this textbook, this particular textbook. I'll put that in the description. But if you have any further questions or problems, really feel free just to send me an email and say, hey, look, I'm having problems with, this part or that part. But if not, I hope these notes help you or someone else. And if anyone else has a question, feel free to drop a comment. Until then, I'll see everyone later.